Hi, today's lesson is similar polygons. The objective is how do we identify similar polygons and solve problems using scale factors. Okay. So before we delve into similar polygons, we need to know what it is, what it involves, and the symbol. So similar polygons basically is same shape but different sizes. And the symbol for similar is a little squiggly line. You've seen that on top of the equal sign when those two put together gives you the congruent symbol. But without that equal sign underneath it, and it just a line, the squiggly line by itself, it means similar. When it comes to similar polygons, there are two things to look for: corresponding congruent angles, and two, corresponding proportional sides. So with similar polygons, you have to have congruent angles and corresponding proportional sides. Unlike the congruent triangle, where if all the sides are congruent and all the angles are congruent, the corresponding angles and corresponding sides are congruent, then both triangles are congruent. But this is different because the only thing that's congruent is the angles, and the sides are proportional. So think of it as if though if you had twins, consider them as congruent shapes, twins. But if you have fraternal twins or someone who's trying to emulate you by dressing like you, talking like you, trying to do the same moves as you, but you're not the same, you're not identical, then you're just similar in the sense of how you dress, how you talk, how you walk, but you may be different sizes or different colors, stuff like that. That's what similar is. So now with the example, it says check whether the figures are similar. Justify your answer by using the chart below. So we have two different shapes. We have two quadrilaterals, and we have to figure out if they are similar. Each side has its own measurements. So we're going to look at each side. Get the pen. So I'm going to look at AB versus EF because A is congruent to E. I can see B is congruent to F. D is congruent to H, and C is congruent to G based on their markings. So I could move this and put it over here and show that what the angles are. All right, now I need to see if the sides are proportional. So I'm going to take AB and EF because A to B has one angle mark to two angle marks, and E to F is one angle mark to two angle marks. So those two sides may have some kind of relationship. So when I look at it, so if I put 5 to 2.5, and then let me take another side. I notice that B has two markings, F has two markings. C, 3, G, 3. So then I'm going to look at the sides. So I'm going to have BC, put a question mark, BC, which is 6, and then FG, which is 3. Now I'm going to compare those two sides. So if I were to do 5 divided by 2.5, it would give me 2, and then 6 divided by 3, 2. Okay, they're in proportion. Now let me look at the other one. Let's see AD versus EH. I see 10, 5. So that means I needed to divide 2 to get to 5. Did I do the same thing for DC to HG? 8 to 4. I divided by 2, so I did half. Yeah, that seems to be what's happening with all the sides. The big shape going to the little shape, I'm basically multiplying by half to get to the dimensions for the small shape. So I can say in conclusion that the sides are proportional. So then I set up the proportion. So one side of the big triangle to the small side is equal to another side of the big triangle to the small side of the other shape. So then I can do that for all of them. They're all in proportion because they have a scale factor. And I figured out that from the big to small, I would have to do half of whatever the dimensions are. And if I did the other way from small to big, I'm basically doing 2 times the measurement. So that is a scale factor depending on which direction I go. So then with all that being said, I can say that ABCD is similar to EFGH because the angles are congruent and the sides are proportional. So I've justified that both of these shapes are similar. So that's how you would do that if you had an example like that. Look at the sides, see if there's a relationship, and see if it happens consistently within the shape. All right. Next one, we got 2 triangles. I noticed one of them, they have a 90-degree marker, but in order to make this easy, maybe some of you are able to look at it and like, okay, figure out which side is in relation to the other side for the triangle. But if that is difficult for you, you can easily just change the orientation of the shape, so that way the 90-degree marker is in the same location, and then the other angles inside are also in the same location. So now you can look at it much easily in a better way. You can see that A and D, they have the same angles, and so does C and F. All right, so once you've put it in a certain orientation so that way you can see it, I could say that the angles are congruent. C and F, 90-degree angles, A and D, 30-degree angles, and knowing that a triangle is 180 degrees, I'm assuming that, I shouldn't assume, it's a fact that B and E are going to be 60 because all together it'll add up to 180. So then B and E are also congruent. All right, so I got the angles. Now the sides. Are the sides proportional? I have to do a test first. I can't just assume unless I prove it. So I'm going to look at 6 to 4.5. So I'm going to put 6 and 4.5, and then I'm going to put a question mark and see if this is equivalent to or proportional to the other side, 12 over 9. So I could cross multiply and see if both sides will give me the same number, or I could just divide 4.5 into 6, and or reduce it. So I'm going to put that and then use math and reduce the fraction. So I would get 4 out of 3. Again, the way I did it, I put in the calculator as 6 over 4.5. I pressed math and I press enter, and then reduce the fraction. And of course, if I do 12 over 9 and I reduce that, the common factor is 3. So there'd be 4 over 3. Yep. So those two sides are in proportion. And I'm assuming those two, by looking at it, even though there's a square root of 3, it would cancel out because it's square root of 3 divided by itself gives you 1. So I'm left with 6 divided by 4.5, which is the same thing as CB and FE. It will give me 4 over 3. So yeah, they're in proportion. So then I can conclude for the sides that AB over DE equals CB over FE equals CE over DF. And I could also state that triangle ABC is similar to DEF because all the angles are congruent and the sides, the corresponding sides, are proportional. All right, let's go on to the next one. Scale factor. You heard me use the word scale factor. Basically, scale factor is a ratio comparing the lengths of corresponding sides. So whatever shape you may have a shape that has 3 sides, 4 sides, 5, but you're comparing the size, the dimension of one shape to the other shape, and see if it is consistent, has a consistent pattern with all the sides. So that is what scale factor deals with. Let's look at example 3. Example 3 says, some special effects in movies are created by using miniature models. In a recent movie, a model sport utility vehicle, SUV, is 22 inches long, was created to look like the real 14 and 2/3 foot SUV. What is the scale factor of the model compared to the SUV? All right, so we're looking at the actual, the model, oops, the model which was 22 inches. All right, let me do that again. The pen is acting up. Okay, so model which was 22 inches long, and then the actual SUV is 14 and 2/3 foot or feet. So now we need to see if what's the scale factor from the model to the actual, or if you do actual to the model. But notice that there's something going on. The model is 22 inches, and the actual is labeled in feet. We need to convert. So we have to figure out the relationship between inches and feet. We know that there are 12 inches in a foot. All right, I'm going to change this and use another color. So that means we need to see how many feet that can we have with 22 inches. So again, it'll be 22 inches, and then we need to know what it is in feet. So we would cross multiply, but in this case we're going to divide by 12 for 22. So when you do that, make sure I have more space here and move this out. Back to green. All right, so then it's going to be 12x and 22, and you divide that, and then we get our, it'd be, let's see, yeah, 1.83 feet. And I want to see if they have, I'm going to put it in a, rather put it in a fraction, put 11/16 for feet. So for every 1.83 feet, it's going to be 22 inches. So now we need to do a ratio to see what they're asking for. So they want to know the scale factor. So if this represents the model, then we have to do the actual. So we're going to do 1 over 1.83 over 14 point, so we got 66. So then we're going to see what the scale factor is, and it comes out to 1.24. And if I were to put that into a fraction, ooh, that's a huge fraction. Okay, so that would be the scale factor, and I would have it as 1, actually, yeah. So it would be 1, oops, gotta get the pen again. It'd be 1 over 7.99. But that would be, it'd be close to that. So it'd be approximately that. But this is the scale factor. So that's how you would do it. So you make sure when it comes to scale factors, make sure, especially with labels, the units, make sure that they're the same. Convert it so that both are the same, and then you can find the scale factor. So it's from the model versus the actual. All right. And the most important thing when it comes to using scale factors is order is important. So the way you set it up, however you do it for one ratio, you have to do it for another. You can't just put numbers whichever, however you want. Order is important when you're dealing with scale factors. All right, so now proportional parts, we're going to apply everything that we've learned, and then we're going to try to find our missing variables. So x, y, and we also need to find ut. All right, so for this one, they said write a similarity statement for the similar polygons. So we know that this this polygon is similar. So we're going to create a statement. And if you remember when we did similarity congruence, triangle congruence statements, it's almost like that, but we're doing it for similar polygons. All right, so use that. And I just write, so for the small one, I'm just going to start with A. So A, B, C, D, E is similar to, if I started here, A, with the angle marker of 1, I'm going to do R. And since I went into this direction, I'm doing the same direction. So R, S, T, U, V. So I mentioned that these two are similar. Now I need to solve for X, Y, and UT. I know that RS, so I'm going to put it here, RS is in proportion with AB, and ST is in proportion with BC, TU, oops, that's not a U, TU is in proportion with CD, and UV is in proportion with DE, and VR is in proportion with EA. So I know the angles are congruent and the sides are proportional. So this is, I'll put the word proportional, because I don't want you to think that it's congruent. It's proportional. So now that I know it's proportional, I can set up a ratio. Now let's see what's the first thing I want to solve. I want to solve for x. So I'm going to have 18 over 4, because those two sides are proportional, equals x over 3. Okay, let's do that again. Equals x over 3. Alright, so I cross multiply. So 4x equals 18 times 3, which gives me 54. And then I'm going to divide that by 4. And then x equals 13.5. Okay, let me erase that and do it per 13.5 meters, since there's a unit. Alright, I found x. Change that. I use another color to find y. Alright, I notice that y plus 2 is for TU, and I know TU is in proportion to CD. So I'm going to use two ratios. I have 18 over 4 equals y plus 2, which is proportional to CD, which is 5. Then I'm going to cross multiply. And again, so that way you know what I was doing. So cross multiplying. So then I'm going to have 4 times y plus 2 equals 18 times 5. 18 times 5 gives me 90. And I distribute 4y plus 4 times 2, 8. 4y equals, since I'm subtracting 8 from 90, it will give me 82. And then I divide 4, and I'll have, extend this page, y equals 22. All right. Oops, not 22. What am I doing? 20.5. My bad. 20.5. But I was looking at an 88. And then box that. All right, so I found y. Now, since I found y, I can plug that into, for ut, I'll use another color to distinguish. So ut, which is equal to y plus 2. There's one more thing that I needed to do with the other one. Put an m for meters. So then I just plug in what I had for y. And then ut equals 22.5 meters. And there you go. You're able to solve 3 different things, knowing that the 2 shapes are similar. And then you just set a proportion and solve for whatever you need to solve for. All right. So we're at the end. Just to recap. Oops. All right, so we learned about similar polygons. I'm so stuck on triangles. We learned about similar polygons. We learned the symbol for similar, which is the squiggly line. We know that similar polygons mean same shape but different sizes. And in order to know that the 2 polygons are similar, we're looking for corresponding congruent angles and corresponding proportional sides. So corresponding angles, congruent angles, and corresponding proportional sides. And when it comes to trying to figure out the scale factor, basically you are observing what is happening to one side, to 2 different sides of one shape versus the other 2 sides of the other shape. And if it's a consistent scale factor going all around for the whole shape, both shapes, then it is similar. And we know that the angles are similar also if there's a marking or if they mention it. And remember, if you're going from large to small, you are doing either double, triple, whatever. And if it's from large to small, then you're doing half or a third. You're going in that direction. Okay, and also, I'm just waiting for this to go on. Otherwise, frozen. Again, we're doing proportional sides, scale factor. If the units are different, make sure you convert and then set up the ratio to find out what the scale factor is. Okay, and then when it comes to using scale factors, order is important. So again, however you set up one ratio, you have to do the same thing for the other ratio. You can't just put numbers however, wherever. There's got to be a rhyme or reason when it comes to setting up proportions. All right, so this concludes our lesson. If there's any questions, if you're confused about something, please email. Do not just leave it and not bother with it. I will help you out. And I can also give you examples and other explanations so that way you can understand and reduce the confusion. All right, end of our lesson. See you around.